Welcome to Class 10 Maths, Chapter 6, Triangles. This is the first lecture in which we shall discuss the basics of similarity, and in this we shall discuss the exercise 6.1 and exercise 6.2. In the second lecture, we shall discuss exercise 6.2 and the criteria for similarity of triangles. While in the third and last lecture, we shall discuss the exercise 6.4 and 6.5. So let's get started. Let's begin by understanding what is similarity. So let's understand this with an example. So here you can see that there are two circles on the screen. So are they congruent? No, because they don't have the same radius. But are they similar? Yes, because they have the same shape. Hence, for two figures to be congruent, they need to be of the same shape as well as of the same size. But for two figures to be similar, they just need to be of the same shape, and they can be of the different sizes. Thus, all congruent figures are similar, but all similar figures are not congruent. So in this case, if we take these two circles, then they are similar because they have same shape, but because they don't have the same size, they don't have same radius, so they are not congruent. Hence, we can say that all congruent figures are similar, but all similar figures are not congruent. Now let's understand the formal definition of similarity. So two polygons of the same number of sides are similar if the corresponding angles are equal and the corresponding sides are in the same ratio. So the angles should be equal, and as well as the ratio of the sides should be equal. Let's understand this with the help of an example. So here we have a question from NCERT textbook 6.1 exercise. The question says, are these two quadrilaterals similar? So there we have two quadrilaterals, one with sides 1.5 cm and the second with side 3 cm. And the question asks, are they similar? So the answer to this question is that no, they are not similar because their angles are not same, though they have the same ratio of sides. So if we calculate the ratio of their sides, then we will get it as similar. So the ratio of the first side is 1.5 divided by 3. Ratio of second side is also 1.5 divided by 3. The third side is also 1.5 divided by 3. And the fourth side is also 1.5 divided by 3. So basically they have a ratio of 1 by 2. But they don't have equal angles. So you can see that in the first quadrilateral, the angles are not equal to the angles of the second quadrilateral. Hence, these two figures are not similar. So from this we can infer that two things are needed for similarity. One is equal angles and second is equal ratio of sides. Now let's discuss similarity of triangles. So two triangles are similar if they have same corresponding angles and equal ratio of sides. Two triangles with equal corresponding angles are called equiangular triangles. The Greek mathematician Thales gave the following rule. He said that the ratio of any two corresponding sides in two equiangular triangles is always the same. So he said that if we have two triangles in which the angles are equal, then the ratio of sides will be equal in that triangle. And he used the basic proportionality theorem for this result. So this basic proportionality theorem is also known as BPT. Let's understand more about this BPT. So the basic proportionality theorem is also known as the Thales theorem. Let's see what this theorem states. So this BPT says that if a line is drawn parallel to one side of a triangle to intersect the other two sides of the triangle in distinct points, then the other two sides are divided in the same ratio. So it's a bit complicated, and let's understand this by drawing a diagram. So let's understand the BPT line by line. So the first line of the basic proportionality theorem says that if a line is drawn parallel to one side of a triangle. So we have to take a triangle and let's name it ABC. So here we have a triangle ABC and it says that a line is drawn parallel to one side of the triangle. So let's take that side to be BC, and we have to draw a line parallel to side BC. And we have to draw the line such that this line intersects the two other sides in distinct points. So we have to draw a line parallel to the BC which will intersect AB and AC in two distinct points. So let's say that this line is line L and it is intersecting the other two sides that are AB and AC in the points D and E. So DE is intersecting AB and EE point is intersecting AC. So here we have DE line which intersects AB and AC in two distinct points and is parallel to the side to the side BC. Now it says that the other two sides will be divided in the same ratio. So it says that the ratio in which AB and AC sides will be divided by this line will be same. So basically AD divided by DB will be equal to AE divided by EC. So AB divided by DB will be equal to AE divided by EC. So basically their ratio will be same. Now let's discuss the proof for this basic proportionality theorem. So we are given that here we have a triangle ABC and a line DE is drawn parallel to the third side of the triangle, that is BC. So DE is parallel to BC, and we have to prove that this line, this DE, divides the other two sides of the triangle, that is AB and AC, into the same ratio. So basically we have to prove that AD upon DB is equal to AE upon EC. So basically I have to prove that the ratio of the AD is to DB is equal to AE is to EC. So let's see how we will do this. So for this we will use the area of the triangle. Let's see how. So here we will draw a line perpendicular to the AD and we will name it as EN. So here EN is perpendicular to AD. Now why we did this? This is because when we draw a line perpendicular to this AD, then AD will become the base and EN will become the height. And as I told you earlier that we will use the area of the triangle to prove this BPT. So that's why we have to take a height and a base. Now can you tell me that which another triangle can be formed by keeping EN as the height? So if we join BE, then we will get a triangle, that is BDE, in which the height will be EN. So as BDE is an obtuse angle triangle, so you know that it will have a height outside the triangle and the height will be EN. So here we have a common height for both the triangles ADE and triangle BDE, which is EN. So here you can see that area of triangle ADE will be half of AD into EN. So area of triangle is half into base into height. So here in triangle ADE we have AD as the base and EN as the height. Therefore area of the triangle is half into AD into EN. And similarly in BDE triangle we have BD as the base and EN as the height. So we will get area as half into base into height, that is half into BD into EN. Now when we divide the both, we get that area of ADE divided by area of BDE is equal to half of AD into EN upon half of BD into EN. Now let's do the cutting. So EN will get crossed, so we'll half. So we will be left that area of triangle ADE upon area of triangle BDE is equal to AD upon BD. So here we have completed half of the proof. We have got AD upon BD and now we just have to get AE upon EC and then we have to equate the both. So for getting AE upon EC, we will take another two triangles and we will equate their areas. So here we will take triangle ADE again, but this time we will have a different height. We will have DM as the height. So here is the construction here, that draw DM perpendicular to A. And the second triangle we will take will be triangle CDE. So we will take two triangles for the next part of the proof, that are triangle ADE and triangle CDE. And this time our height will be, our perpendicular will be DM. So again we will take their areas. So this time for triangle ADE, the area will be half into base into height, that is half into DM into base, that is A. So basically half into DM into A. That will be the area of triangle AD. And second time for triangle CDE, we will have half into base into height, and base in this case is CE and height is DM. So we will get half into CE into DM as the area of triangle CDE. Now we just have to divide the both. So area of CDE, area of ADE divided by area of CDE is equal to half into DM into AE upon half into CE into DM. So DM will get cut and half will get cut. So we will get it as AE upon CE. So now we have got two results. This is our equation 1, which states that area of triangle ADE upon area of triangle BDE is equal to AD upon BD, and this is our equation 2, which states that area of triangle ADE upon area of triangle CDE is equal to AE upon CE. So we basically have got both halves of this proof, but now we have to equate them both. So let's see how we will do this. So in class 9th, we learned a very important theorem, that if we have two triangles between the same parallels and having the same base, then their areas are equal. So if you can notice that in this case, triangle BDE and triangle CDE are having same base, that is DE, and they are between the same parallels, that are DE and BC. So from this, can we say that area of triangle BDE will be equal to area of triangle CDE? So this is because they are having the same base and they are between the same parallels. Therefore, area of triangle BDE will be equal to area of triangle CDE. Now, when we have proved that both these areas are equal, then here you can see that we will get, because ADE triangle is common in both, so we will get the left hand side of both these equations as same. So basically we can rewrite the equation 1 as area of triangle ADE upon area of triangle CDE, because BDE and CDE, the area of BDE and CDE is equal to AD upon BD. And the second equation is already area of ADE upon area of CDE is equal to AE upon CE. So from this we can say that area of so we can say that AE upon CE is equal to AD upon BD. So as the left hand side of both these equations are same, we can equate them and we get this result that AE upon CE is equal to AD upon BD. and this was what we had to prove. We had to prove that AD upon DB is equal to AE upon EC, and we have got the same result here. So basically we have got that AE, which is this, upon CE, which is this, is equal to AD, which is this, upon DB, which is this. So basically we have got that the ratio of the sides of AB and AC is same. Now let's practice a question based on basic proportionality theorem. And this question is from exercise 6.2 of NCERT textbook. So the question here says find EC. Here we are given with a triangle ABC and the side DE is parallel to the side BC of this triangle. And here we are given that the length of AD is 1.5 centimeter, length of DB is 3 centimeter, AE is 1 centimeter, and we have to find the length of EC. So now we know that DE is parallel to side BC. Now as DE is parallel to side BC, so by the basic proportionality theorem we get that AD upon DB is equal to AE upon EC. Now just put the values. So we will get that 1.5 upon 3 is equal to 1 upon EC. So now you just have to find this value. So we will get that EC, if we take EC up, this here and this here, we will get that EC is equal to 3 upon 1.5. So we just transpose the variables and we get that EC is equal to 3 divided by 1.5, which is nothing but 2. So the length of EC is 2 centimeter. And we got this by using the basic proportionality theorem. Now let's understand the converse of basic proportionality theorem. Now this says that if a line divides any two sides of a triangle in the same ratio, then that line is parallel to the third side of the triangle. So basically here we have a triangle ABC and it is saying that we have to make a line that divides any two sides of a triangle in the same ratio. So here I am making a line DE which divides the side AB and AC of the triangle in the same ratio. So basically AD upon DB is equal to AE upon EC. So AD upon DB is equal to AE upon EC. This is given to us. So we are given that we have made a line which divides the two sides of a triangle in the same ratio. So in the BPT we had to prove this, but in the converse of BPT we are given with this statement that AD upon DB is equal to AE upon EC. Now this says that then this line is parallel to the third side. So this line, that is DE, is parallel to the third side, that is BC. So basically DE is parallel to BC. So mathematically representing the converse of BPT, we can say that if AD upon DB is equal to AE upon EC, then DE is parallel to BC. So this was all about this lecture. In the next lecture, we shall discuss about similarity of triangles.